In this tutorial, we're going to talk about three-dimensional figures. So the three-dimensional figures that we're going to be talking about are called polyhedrons. And polyhedrons are solids with all flat surfaces that enclose a single region of space. So I have drawn a three-dimensional figure, which is a polyhedron. And in this particular picture, all of the surfaces, all of the sides are all polygons in themselves. So if you look at this front side right here, this piece right here, notice that it is itself a quadrilateral. It's a four-sided polygon. Specifically, it's a trapezoid. The part on the side, this one right here, if you were to actually look at this on that side, it would be a rectangle. So again, all the sides are simply polygons. So the polygons, or the polyhedrons, have different parts of them that we need to know. So the first one that we're going to talk about is a face, and that's what we were just talking about. It's the flat surfaces that make up the polyhedron. So all the flat surfaces. The other part that we need to know is the edges, and the edges are simply these pieces right here. So all of these intersecting planes are what we call the edges. And the last piece that we need to know are the vertices, and that's where three or more edges intersect. So for example, if you look in the back part, this invisible edge, this one, and this one, where they connect right here in the back, that is called a vertex. So there we go. So these are all of the main parts of a polyhedron. It's like the building blocks for it. It's all the vocabulary that we need to know. So what kind of polyhedrons are there? There's a few actually, and we're going to cover them in this tutorial. Okay, so polyhedrons, or polyhedra, that's how we can say it plurally as well, are named by the shape of their bases. Keep in mind that the definition of a base is two parallel congruent faces, and remember that faces are the same thing as sides. It's just the planes part of the polyhedron. Okay, so let's go ahead and name a few. So here's our first one, and what we're going to do is try to identify the bases first. So they have to be parallel, and they have to be congruent. And the two parallel sides I see is this piece here and this piece here, which would make that a triangular polyhedron. And in this case, we call it a prism. So now we have this one, and again, we want to identify the parallel sides, and there should be two of them. So I'm seeing these end pieces here as the bases, which means that this is a rectangular prism. Granted, those could be squares, but we always stick with rectangular. Alright, and for this one, you'll have to excuse my terrible sketch of this, but this is a pentagonal prism. So we're going to identify the two congruent parallel faces, which should be pentagons, which are going to be the top and the bottom parts of this polyhedron. Okay, so what if it's not a prism? What if we have polyhedrons that don't have two parallel congruent faces? Then they will typically be pyramids, and we're going to take a look at a few. Besides that, there's some very special ones that are called Platonic solids, and we'll review those after we go over the pyramids. So let's do that first. Okay, so let's take a look at the pyramids. So the definition of a pyramid, it has to have a polygonal base and three or more triangular faces that meet at a common vertex. So just like the Great Pyramids in Egypt, all of the triangular sides, they go up to one single point. So that's what we're going to take a look at. We've got three of those that we're going to cover. So for the first one that we're going to take a look at, again, we name all pyramids and all polyhedrons by the shape of their base. And in this case, the base that we have is a pyramid, so this is called a triangular. I'm sorry, it's not a pyramid, it's a triangle. So this is a triangular pyramid. So for this pyramid, if we look at its base, it indeed looks like a quadrilateral, so we are going to name this a rectangular pyramid. And the last one that we're going to take a look at, we're going to look at its base, and it looks like it has 5 sides, so therefore this is going to be a pentagonal pyramid. Okay, so next we're going to discuss these special Platonic solids that I was talking to you about earlier. And these are what we call regular polyhedron. Regular is a really important word in geometry because it means everything is congruent. So basically, if all of the faces are regular, congruent polygons, so all the sides are the same, and all the edges are congruent, that means in terms of their length, if these conditions are met, they're called regular polyhedron, which are also specifically called Platonic solids. And these are actually pretty special because there are only 5 of them. And they are very detailed to draw, so I will not be drawing them in this, but I will review with you exactly what they are. So I'm going to list out all 5, the names of them, and then we'll go over what their properties are. So here are all the names. We have a tetrahedron, a hexahedron, which is the same thing as a cube, because hexa means 6 and a cube has 6 sides. Octahedron, which is going to have 8 congruent polygons, dodecahedron, which is going to have 12, and an icosahedron, which is going to have 20. So more specifically, a tetrahedron has 4 equilateral triangular faces. A cube has, of course, 6 square faces. An octahedron has 8 equilateral triangular faces. Dodecahedron are 12 regular pentagonal faces. And icosahedrons are 20 equilateral triangular faces. And these polyhedra are actually really beautiful to look at and observe. We only have one more concept that we are going to cover, and then we'll be done. So last thing we're going to cover is surface area and volume of these polyhedron and other three-dimensional figures. So before we go over the formulas, it's really important that we understand all of the variables and what it's asking us to find. So if we see the letter S, that's going to represent surface area in this textbook. You may also see surface area represented with an S and an A for a surface and then area. P is perimeter, V is volume, R is radius, B is the area of the base as long as it is a capital B. That's really important in formulas for mathematics. The next one is also very important. When we see an H, it's talking about height, but the symbol that I put right next to it, that upside down capital T, that means perpendicular. That means that it is the height from the tallest point straight down to the base. So this is not a slanted height. This is straight from the top to straight to the bottom, creating a 90-degree angle. If you get lost or if you put one of these variables with the wrong number, chances are it's going to be one of these that is wrong. Particularly height. It's always missed. And it's very easy to miss, so just be really careful with that. So let's go over some common surface area and volume formulas for your 3D figures. Okay, so here are the 5 figures that we are going to figure out their surface area and volumes for. So prisms, again, are the figures, the polyhedron with 2 parallel congruent sides. So surface area for all prisms is S equals perimeter times the height plus 2 times the area of the bases, because there's 2 of them. The volume is simply the area of the base times the height. The next one for regular pyramid, the surface area is equal to 1/2 times the perimeter times the slant height plus the area of the base. And the volume for all regular pyramids is 1/3 times the area of the base times the height. Next, a cylinder. Cylinders are like cans of soup. It's got circular bases in this case. So this means that we're going to see some radii come into play. So the surface area, it's a big one. The surface area is 2 pi times the radius times the height plus 2 times pi r squared. Because pi r squared is the area of a circle, and there's 2 circles that make up a cylinder. So the volume part is pi r squared times the height. Next one, we have a cone, just like an ice cream cone. It has one circular base. So this is going to also include radius. So the surface area is going to be pi times the radius times the slant height plus pi r squared, because that's the area of its base. And the volume of a cone is 1/3 pi r squared times the height. And last but not least, we have a sphere, like a globe, and the surface area is 4 pi r squared. And that's kind of weird because it ends up being equivalent to the area of 4 circles. I'm not sure how that works, but it's pretty cool that it does. The volume is 4/3 pi r cubed. So there's all of the surface area and volume formulas and what all of the variables mean. So I do want to walk you through one pyramid problem, just so that we can make sure we understand the height versus the slant height. Okay, so here we go. We're going to find the surface area and the volume of this pyramid. And here are our formulas to work with, and we're going to be given some lengths. All right, so in this picture, we're given some pieces, and granted we may not have all of them, but this is what we're going to have to work with. So let's go ahead and start filling in my surface area formula. So the 1/2 will stay the same. I now need to figure out the perimeter, and this is perimeter of the base. So if this base is a square, which if this is a polyhedron and it's a regular pyramid, then this will have a square base. So since all 4 sides are congruent, we're going to take 6 and multiply it by 4 to get the perimeter, which is equal to 24. L is the slant height, and the slant height is this part right here in green. Okay, it's the slanted part of your pyramid that goes up to the tippy top. That's your slant height, which is 5 centimeters. So times 5. Plus capital B, which is the area of the base, and the area of any rectangular polygon or square is side squared, or length times width. So this is going to be 6 times 6, which is 36. So we work this out, and half of 24 is 12. And then times 5, and then plus 36. And 5 times 12 is 60 plus 36, which is equivalent to 96. And this is centimeters squared, because this is an area value, and all area is represented by a squared. So there's our first one. So let's go ahead and tackle volume. So it's a much shorter formula. So we have 1/3 times the area of the base, which we already calculated to be 36, and we're going to multiply that by the height. And the height is the perpendicular height. That's what I was talking to you about before. So the way to do it is find the tippy top of your pyramid and follow it straight down till you see that right angle, which is right here. Okay, that's how I know that that's the perpendicular height. Okay, I don't even see it. It's completely hidden inside the pyramid. And that has a height of 4. So all together, we're going to take 1/3 of 36. In other words, we're going to divide 36 by 3, which is 13. And we're going to take 13 and multiply that by 4. And that's going to give us 52. So we need our unit, which is centimeters, and all volume is always dealing with 3 dimensions, which is why it has a cube. And that is all we need to do. And that will complete this tutorial.